Good morning. This is maybe Old Salt Gamer. I'm here at my brutal Mars setting station, and we're going to do some really basic coding, and I'm going to keep everything as simple. If you watch the YouTube videos, a lot of them uh, talk above your head, at least for me. and this is going to be beginner, maybe a little intermediate, but you should be able to take from this episode how to use the integrated chip, the housing, and then I have both buttons, levers, switches and levers, and that's what we're going to do today. We're going to use these buttons, levers, and switches to control these two LED lights. So you can walk into your room, and this won't work, but before I program the occupancy sensor in here, which is right here, before I program that, I would come in here and have to turn the light on. But you can see, since I'm standing in here, the light's going to come back on. If I go out here, the light shuts off. That's using the occupancy sensor, which I'll get into in another episode. Pretty simple. But instead of coming in and turning the lights on and off, maybe we could set a switch or lever, and we'll have some fun with this. We'll make it change colors and things like that. Now, you could use the laptop or the computer. It works the same. So what I can do is I can name this. Let's name this housing. We'll just call it test housing because I called all the switches. I named everything. Hopefully you know how to name stuff. If you're new to the game, just use the labeler and you right click on it, and I named this the test lever, the test switch, and the test button, and then LED 1, LED 2. So I could come over here on the computer with an IC motherboard in it, and I could come up here and I could go to the test IC housing, and I can import it, and of course you can see it's blank. Now, just to keep me from running back and forth, I'm going to use a laptop, which is a lot easier in the long run. Let me put this a little closer. I'll probably step on it a few times and kick it, but that's life. So, here's the integrated chip. You can get both of those, the housing in it, and you can integrated chip from the Electroprint. You can get them at level 1. You don't need the mod on it, of course. Now, I loaded in the little section there, and I want to clear out. That's my solar program. Now, let's go over a couple things here first. Notice the housing has 6 device enablers. I guess we'll call them device enablers, and they're D0 through D5. Kind of important, because you see, if you notice, I have 1, 2, 3, 4, 5 devices. So, I knew that was going to happen. So let's go in here. The first thing you want to do, I didn't confirm that. The first thing you want to do is say, which one of those device pins, what are they going to do? So let's go, spell it right first, alias. Alias is just assigning a device pin, in this case, to a name to make it more easier for you to understand. You can also, there's 16 registers. I believe it's 16. Again, this is an intermediate level. I'm trying to make this simple. So you can also, we'll get into that a little later probably. Well, we will. So let's call the device, we'll call it test button. And you can put any name in there you want, and then you can just put D0. That's saying I'm going to connect the test button to pin D0. And then I'm going to connect I did it again, didn't I? Test lever, and you can put these in any order, it doesn't really matter. The D1 alias the test. What else is there? Switch. Oops. TCH to D2 and LED. Oops. Alias. I'm getting ahead of myself. LED1 to D3. Alias LED2 to D4. So even if it's D4, I defined 5 devices. So now, if I did this, this is called a loop. Now I'm just going to set it to a loop that's not doing anything. So while this program runs, it'll go through this section once, and then it'll just say start, jump to start. So then it's just going to keep doing this, boom, 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 over and over. So we're going to do that. Export it. Now I exported it to the chip. Now I have to put it in that chip. Alright, that is a little bit in the way. Let's move it over here. There we go, that's better. Now, how do I set these? You see it says no device. How do I set these up? You turn this on, it'll give you a momentary green light and then or light, and then it'll start flashing. It's not flashing because in this case I don't have a program. If you have a program in there, it'll tell you to define these. If you use test button in a program, it'll say, hey, you haven't defined test button, but that's okay. So now you need a screwdriver. You see test button. Now all these are wired. You see there's a data side and a power side, or 2 data sides and the power side. Most of them have a data power, like this one will have a data and a power all in one. But you see these have datas, and that has a data and a power. Those all have to be interconnected. You can, with this type of stuff, you have to connect both sides. There's no way around it. But so let's go over here, test button. So you just right click with the screwdriver in your hand until you find test button. Now there it is. I'm going to have a lot of stuff on here because my whole base is in here, so usually it's a lot easier than this. So there's test button. You see you set alias to test button and you selected test button. So now you know you're correct. Same thing with test lever. Like I said, this is my whole base. I should have put something in between this to isolate this and make it go a little faster. Test lever, there we go. Then we have test switch, test button. And usually they're in alphabetical order, but it does take a little bit of time for the program to put it in completely alphabetical order. Test lever, test switch, test switch, test switch. You can see my base is kind of big. Test switch. Okay, so LED1. But you get the idea. You just have to identify what pin is connected in LED2. LED1, LED2. Okay, so now we're all connected. Now if I turn that on, it won't give me any errors. So that is the beginning. Now this is an empty program. Everything's set up, but it's not telling it to do anything. It's kind of a waste, right? So first thing we want to do, let's do the lever. And edit this. So let's make some space between there because we want to do, this is going to be our main loop. So let's say now the load, when you load something, and this is a recent change to the program, they do have syntax for all this, it helps. Load, and we'll say we need to put a register. So you could just use R0. R0 is what most people use as a temporary throwaway register. It's just taking that register slot and using it in the program, and you can use it over and over and over, and that'll become more clear here. Now notice it says D. So it's asking for a D, a device pin, but we're going to use the lever. So instead of using D1, to make the program make a little more sense, you put test lever, and if you got it spelled correctly, it'll turn white. You see, if you got it spelled wrong, it's saying I don't know what that is. Caps and case, it doesn't matter. If I make this capital test lever, it's red, because now it says I don't know what that is. Caps and it's a thing that's going to throw you off a lot. And another thing I should put in here now, you put a yield in here. What this does is a yield, for every tick the game goes through the programs, the way I understand it, all the programs that you have programmed, and it's going to, at that tick, stop at a particular point. Now, it's safer to put a yield in your programming to have it stop at this point, so it's not stopped later in the program. It's just a safety device. Everybody recommends it. I use it all the time. Apparently, if you don't, you can get some funny things happening with your programs sometimes. This is just telling the program, hey, when you get to here, hold for 1 tick. And that is telling the program, wait here until the Stationeers program goes to the next tick. It makes it a lot safer to program that way. Okay, so now we have load into register 1, test lever. Now you got to tell it what do you want to load into from test lever. Now I know for a fact test lever, what I want to do is the setting, and watch this how it changes color. Setting, see how it turns yellow? Remember I said caps matter? If I put setting in there, it's red. It's going to give you an error. All the logic types are capitals, and you can get logic types by going into lever. So if you do lever and come down, here you go, setting. This is the logic types that you can read. You can read open. You can do open and closed instead of setting, and that might be the better way to go too. You very seldom use lock. I don't understand why you would want to lock your lever, because then, unless you're using it in a program and you don't want to accidentally hit the switch. But you don't use lock very often. There is some advanced programs where you can use the prefab hash and those things down there. We're not going to get into that. But I'm loading the setting. Now, what am I loading from the setting? It's going to give you 2 numbers, and you can get these, and I'm going to, I am in a brutal Mars setting, so I am going to have to drink and eat a lot, so you'll have to forgive me for that. I don't usually put these in my video, and this will show you, if anybody else is watching my Brutal Mars series, this will show you how often you got to do this. It's crazy. You're constantly eating and drinking in the brutal settings. So like I said, you'll have to forgive me for this if you're on this for the program. Okay, back to our show. Now, where was I? If you look at this, it says 0. So what I'm going to actually do, state 1, state 0. So let's go ahead and use open. Probably a better thing to do on this one. You can do this any way you want, and it's always fun to test these things. And then, okay, so if I just read open, what am I going to do with the open condition? So now, I'd say I want to use the lever to turn the LED lights on and off. So now I can put break less than, and so if it's less than 1, well, we got to R0, the register R0, which I loaded the test lever open setting into. Break less than R0. If it's less than 1, I just want it to go to start. So, because that turns everything off. That's saying, hey, he has the switch off. He doesn't want to do anything. So it's just going to go down here and go to back and forth to nothing. Now, I could put greater than 1 then and use another line, but why bother? Because now I'm saying if it's off, just go back to start. So what I can do here is assume that the open lever is in the position 1 because I didn't jump to start. So now I can do save LED 1, and let me type this out first, and then I'll explain to you on 1. So when you save, and this is confusing, it gets you until you get used to it. When you load, you have to put the register first. When you save, you have to put the device first. So you save the device, and I could also do it that way too. Save the device LED 1, the on position to 1, which on has 1 and 0. It's like a binary. If 1 and 0, so if it's you set it to 0, it's going to turn it off. If you set it to 1, it's going to turn it on. But why would I want to use 1? I could use my register setting R0. You could do 1 or R0. Both would work, because R0, after you load the test lever, if it's open, it'll be 1 if you turned it on. So we'll just use R0. I hope I'm not going too fast for all this. I don't think I am, but so then that only takes care of 1 LED. So then save LED 2 on R0. Now, that'll do this, and then it'll go back to start. So it'll keep looping through this. So if I did this right, and we export this, and I put that in there, and I turn this on, hopefully it doesn't flash at me. It doesn't. So now the lever's closed. So when I pull this, it turns the lights on. If you're using, there are some cases when you have to use logic writers and logic readers, but that takes a lot of cables and a lot of unnecessary stuff. IC chips are the way to go. Once you learn how to write programs, you almost never use these, and this is the only case that I have because I could not read my water tank level without a batch reader, which was, and to export it to a graph. So I had to use those. There are cases where you have to use them. Notice everything else I have over here is all IC programming. All these lights, graphs are all set up in 3 different IC programs. One of the limiting factors with housings and IC housings is you only get 6 pins. So you notice I have 9 lights and 9 displays. Well, guess what? You can't do 9 lights and 9 displays with 1 housing. You can only do 6. So that's why I have 3 of them. But anyway, back to the program. So there you go. So this little line of program turns on and off the light based on where you have the switch. Okay, why didn't it turn off? Error bugging. You have to debug your programs. So I went back to start. Let's see, test lever open. It should reread that again when it goes back to start. Why didn't it turn it off? Because I didn't tell it to turn it off. Now, why did that happen? What I gotta do is if it's 0, if it's less than 0, I just had to jump to start. Well, it turns out you can't do that. So let's put another loop in here. And I call these very simply turn off. Now, why is that red? Because I didn't define turn off. When you define a separate loop, you have to put a colon after it. You don't want to put it in here. This is a separate branch. So now I'll put down here turn off, and I put a colon after it, and watch. That red goes away. Because now it says, oh, I know where turn off's at. We're good to go. Now, I basically duplicate these programs on turn off, and I put Matter of fact, we could do this. I could just copy these because I used the register number, so I could just highlight it, Control C, bring it under turn off, Control V, and do the same thing here. Highlight, Control C, Control V. Now, I told it to turn off. What happens if I just do it like that? It'll turn it off. But guess what else it's going to do? It's going to end your program because you didn't tell it what to do after that. After you turn it off, it's going to go down here and say turn off. Oh, okay, I'm done. So you have to jump back to start. Remember, capital letters. Excuse me a minute. Sorry, I had to cough. So there you go. Now, if I confirm this, take the pin. Notice when you pull the pin out, it says, hey, I'm confused. You just turn that off. Export it. Plug it back in. Now, as soon as I turn this on, it should turn the lights off. There we go. So now, I can turn the lights on, and I can turn the lights off. So that is the basic setup for turning lights on and off. Pretty simple. I could clean this up a little bit so you can look at it real quick. Again, the main loop is start. Anything you want to loop out of start, you want to make sure you loop back into start. So if you have the switch turned off, it's going to jump to turn off every time and then jump back to start. If it's turned on, it's going to skip this line because it's not less than 1, and it's going to turn them on and then jump back to start. It'll just keep doing that. So no matter where you have the switch, we're in a complete looped program here. There won't be any breaks where it's going to say I'm over. It's just going to keep looping on and on. So that's the lever, open, closed, switch. What do we want to do with the switch? Okay, so let's say we want to control one of the lights. Maybe we don't want both lights on at the same time when we turn this on. So now we're going to load the switch. So let's have the switch control either one of these. If I turn the switch to closed, maybe only LED 1 comes on. If I turn the switch to open, maybe only LED comes on, even with this setting. Now, this could be interesting because we're going to have competing jumps. This one's going to be telling them both to come on and off, and this is going to be telling one to shut off. So it could get a little interesting. Let's try this. What did I call this? Test switch. So let's go in here. Before I go to turn on, there's an easy way to do this with well, not easy, but with using the registers. That's why it's better to use registers, because you can change those. So jump to turn off. So this is going to be where we want to turn it on. So now I can say jump, or let's see how the best way to do this. Load. I can't use R0 in this one because I'm already using it, so I can do R1. Load R1 test switch. And we'll do open again. Now, let's do another thing here where we go see, now we got to be careful when you get multiple jumps in here. If I put a jump and then jump to start, well, it's going to jump back up here and it's not going to finish the rest of this program. So maybe I don't want to jump here. Maybe I want to just do how can I do this? I could do a jump relative, but that might be too soon for that. I may have to, though. or just make this a whole separate thing. Let's do that. Let's try and work this out together here. So, let's say break less than, if it's not, if R1 is less than 1, then jump LED, we'll call it, oh, no, I don't need to do that, not jump, LED 1 off. And then you could do, instead of putting something else in there, you could just put jump LED 2 off. Okay, this is, with this switch we may be able to get rid of this whole section here because we're changing the program's meat completely. So we'll just keep going from there. So now we'll put, let's leave a space, LED off, oop, LED 1 off, and put a colon after that. I did something wrong. LED 1, oops, off. There we go. Okay, so if LED 1 is off, then we want to save. I can just use this. LED 1 off, so we can change this to 0 and change this to 1. So in this case, since we're overriding R0, we would want to use these specific settings. So there's LED off. Now, I'll leave a space again. LED 2 off. And again, I'm trying to keep this as simple to understand as possible. I'm sure I'm going to get comments from somebody saying you could do this better this way. Absolutely. And I'm trying to make this, I want to use the saves, break less thans, and you can also use break greater thans. You would just have to change this to 0. So anyway, now I could just, let's get rid of, I'm going to have to modify this program now. Let's just get rid of that, bring that up, jump LED 2 off. So now I want to set this one to 1 and that one to 0. But you notice I got a red up here. It's okay, I don't need that anymore. I'll just delete that whole line. So, how do I control the test lever now? Because I just got rid of that whole line. Very simply, I could change this to where I make another loop. So if I load the test lever open and it's less than 0, BLT, or less than 1, R0, 1, that means I want both of them off. So now I can just do a turn off and put it down here outside the loop, just like I had it before. Turn off with a colon and set LED 1 on 0, set LED 2 on 0, oops, 0, put a space in there, Steve, on 0, and then jump back to start. So there, with that, caps, with that, I'm now covered. If I want them all off, then it goes down here and turns them all off. If I want to use the switch, then I'm going to have the switch set 1 on and off. I have that covered too. That should work. Oops, I got to export it. I am not an expert programmer, so don't be surprised if this does not work. Here we go again. That's what I'm talking about when guys I talk to people about constantly having to drink. Okay, so if I turn this on, test lever set to 1. Oh, I didn't turn it on. There we go. Now because I have this set to closed, LED 1 comes on. If I change that, that's interesting. What did I miss? Let's find out. Let's stop that because that's annoying. So it's looping back and forth between the two settings. That tells me I missed a jump start. And right there it is. When I have it turn that one off, I don't have a jump start in there. And of course I didn't use capital letters again. I very seldom use capital letters on my names for exactly that reason. Now, since after it turns that one off, it jumps to start, that should not happen anymore. And this is where your bugging comes in. Okay, switch. There we go. So that's solved. What was happening in there, in case you don't understand it, is since I didn't have a jump start here, it just goes to the next line. So it went to jump off, turned correctly, and then skipped right into LED 2 off and switched it. And then it jumped to start, and it would turn it back to this one, then back to that one, and it just kept click, 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 click. So you have to make sure you branch when you need to branch. Okay, so that is the two switches. We got that working. Now, buttons are a little different. It's basically a one-time hit. So, what is this setting? It's a state. State 1, state 0, state 1, state 0. Now, these are also called a state. So this can probably be open and closed too. I don't use buttons very often. Let's see, is it setting? There is no open, so it's setting. So we're going to have to use a different, or activate. That's what I want to use, activate. Okay, let's try activate. Activate means, is the button pushed? Now it is, now it's not. Now it is, now it's not. So, what can we do with the activate button? And where can we put this? I think we can change these 3 jump starts. The jump is activated. And I'm going to copy that. Sometimes it's easier to do this. Sometimes this is kind of dangerous because you put them in the wrong spot and then you... What are you doing? Come on. Control V. Control V. So, let's make this is activated with a colon. And that should get rid of all the reds. And it did. Make sure you check that because you'll have an error if you don't. So what are we going to do with this? If it's activated, let's swap the colors out. So, LEDs, let's look up LEDs. LED light. See, it has colors. Now, if you come down here to colors, well, what can I do with colors? If you right-click on it, there you go. You have all sorts of colors you can change these to. So let's just pick blue and green. So we want color 0 and color 2. 0 and 2. I'm going to just set that down here. 0, 2. That is not a, that's just a reminder to me. Okay, so if it's activated, let's see, load. Again, this is a generic one. Since we're not currently using anything, we could use R0. Device LED 1. And we could just use one of them or 2 of them, however we want to do it. LED 1 color, capital, remember capital color So now I just loaded into R0 the color of LED 1. So then I want to say break less than color. Well, let's do equal to. Equal to just says it equals this. Does it equal this number? If it does, branch. Now, when I set this, what is white? That's a good question. What color is white? 6. Does that matter at this point? Let me think for a second here. If it's equal to, let's do this. Maybe I have to go up here. Let's do this. This is a good way to do it. Remember I said you could define registers? Let's alias color, and let's make them blue to start with. Color R0. Can I do that? Alias color R0. No, I can't do that. I don't want to alias a color. I want to alias a register to 2. So let's use register 10. That's another one that I use just because it's handy. So I am setting the register R10 to 2, or the color, whatever that color was. So now that's done. I go to move that up. So when I turn these on, how do I get those to, how do I get it to know that? I'm going to have to add some lines. Maybe I could do that up here. Got to be careful though, because if I jump to start, if I define the color here, it's going to change it back every time. So I can't really do it up there. So let's go down here and do load RD color. Let's so it'll be white until we activate it the first time, the way this program is going to run. Or I could do this. Now remember, anything you put up here is only going to run once. So let's do this. Set LED1 color. Oops. Oh, capital letter 2. COLOR color 0. Let's set it to 0. Set LED2 color 0. Now remember, that'll only run once. It won't change it because it's only going to jump back to start. So that'll set the color to blue at the start of the program. So that's very easy, very simple. So if it's activated, I want to load the color. If the color equals 0, R, blue, jump, nope, R0, wrong, R0, 0. If register R0, which we loaded there, is 0, then jump. It keeps spelling out jump. I don't have to do that here. I'm thinking and spelling at the same time. If it's 0, go to, what was the other color we selected? Green. So I'll just name this green. Otherwise, save LED1 color 0. Okay, now I've only changed one color, right? I got the 2 lights which are controlled by different switches. So it doesn't matter because they're still going to be the same color based on the activate button. Even though one's going to be off, it's still going to be the same. So I really only have to do LED1 because I set both colors. But I also have to set both colors here. Set LED2 color 0. And of course I didn't use the capital C. Now, what happens if it's activated and the color equals 0, it goes to green? Well, then I have to go down here. We're going to get rid of those because I know the color is now 2. So I'm going to call this green and put that. That should get rid of the red. It did. It's going to jump to green, and we'll set LED1 color 2. Set LED color, I gotta change that, but put 2 there first. This is LED 2. And now this activated loop is I got a storm going on outside. is now complete. So I want to jump back to capital START, jump start. So this is a dangerous thing about programming live. This should work, but I might have bugs in this. You always have to debug your programs, at least I do. So let's turn this off and export that and put it back in here. Now theoretically it should turn the color to blue. I have a problem. What's it saying? Unknown error line 5. What did I do at line 5? It does not like alias R102. You know why? Because I'm not aliasing it. I am moving it. Move R102. Basically that is just saying move a number into that register. So let's try that. There we go. And why is it changing? What did I forget again? And is that green? I'm colorblind. I guess that's green. So I forgot something. Probably a jump again, didn't I? Yes, I did. It's activated right here. I didn't put the jump start in there. So it went right back to green. Usually if you get something like that, it's because you forgot to put to close a loop out. And it's still not working. Oh, did I export it? I didn't. Yes, I did. It's still changing. Well, let's see what else I forgot. Turn off. Then it's going to is activated, going to is activated. It is jumping between the colors. Load. Oh, you know what I forgot to do? I forgot to see if it's activated, if the button is activated. So it's going to is activated and just changing the color because I didn't set a setting in here. BL, if it's less than, if, I gotta load it first. Load, and I can use R1 here, or R0 here. Load R0, test button, activated, activate, activate, there we go, activate. So now I'm loading the activated condition into R0. So it's not activated. So if it's less than BLT R0 1, if R0 is less than 1, go to start and capital S. That should fix that issue. Export. There we go. They're blue. They're staying blue. If I turn this off, they turn off. If I turn them on, that one's on. This one's blue, but it's not on. It's hard to see. And what happens if I turn this on? it'll turn it right back off because the program's saying, I don't want that on, I want it off. But if I switch the switch, now that one's on. And if I did the same thing here, the computer's, the IC program is controlling it. Now the test of the new thing. Let's activate the button. It changed it. Changes it to green. Now if I hit it again, it changed it back to blue. That worked out far better than I thought it would. So there we go. I used the button, the switch, and the lever. And let's go over this one more time. You can stop now if you think you understand what I did. So all I did was I aliased the devices I was going to use. I moved. Moving is just putting a number into a register. So I moved. You know, I actually don't need that. I actually don't need that. Let's take that out and see if it still works. Let's take that out and see if it still works. I don't think I need that. Export. I don't need that because I set it after that. Yep, I don't need it. So what I put that in there for was to set this to R10, but I defined the color as 0, so I set it. Remember, this only runs when you first start the program. So that's that part. I got rid of the move. That's any line you can get rid of after your testing is a good thing. Excuse me while I take care of my brutal settings here. I'm just going to eat. I'm almost done, so I'm just going to eat this. It'll still be hungry, but enough to get through the alarm. Okay. So remember, start is our main loop. You always want to go back to the main loop after you separate from a loop. Otherwise, you're going to end up ending your program or having funny loops that turn lights on and off and that sort of thing. I explained yields. You want to put a yield in there. It tells the computer it's okay to stop here when you need to stop. The program, it says that. Load. You're always loading something into a register. It can be anything into a device of a type that you're working with. In other words, a lever has open, and you can always check that by just going in here and typing in lever like I showed you, and it'll go. These are the ones that you can use in that area. The main ones you're going to use for buttons and switches is open and setting. That's the main ones. So if it's less than 1 or if it's 0, I could change this to BEQ, which was BEQ R1 0, and it would do the same thing. I like using less than because some things you have more than on or off, and if you use less than, what happens if it's -1 and you use BEQ? Well, then it's going to give you a negative result. I like using less than or greater than. It's a safer way to go. BEQ you can use if you know for certain, like down here, what you're looking for. Anyway, so less than turn off. I jump down to turn off. It turns everything off. It jumps to activated here. Technically, I could jump to start here because the LEDs are all off. Why not? Let's see if that works. I could jump to start here because it doesn't matter the rest of it because everything is off. And again, this is the fun part of this game where you can just play with stuff. Let's see if I broke the system. Now why did it switch it back to blue? Because it ran from the start and it switched it up here. So every time you pull this out, if I did this, and pulled this out and plugged it back in, it's going to switch it to blue because it runs that program once. Let's check all this. It turns them off, turns it on. See, I didn't need that jump start there. Switches between one light and another light. Change it to, uh-oh. Oh, you know why? This is one of the problems with buttons. The program ran so fast that it was still counted it as activated. I wonder how often that would happen. So that is going to be, there it goes again, that is going to be a random occurrence, because that's one of the reasons I don't like using buttons. If it goes through a tick and senses activate, it's going to change that. But if it goes through it again while it's still in the activated condition, it's going to switch it again. So buttons, don't be surprised if every once in a while it reads a button twice. It seems like there it did it again. It read that button twice, so it switched it to green, went back to the beginning of the program, said, oh, I'm still activated, and switched it back. So that shows a very interesting problem with buttons. There it did it again. So maybe 1 out of every 5 times. How could I fix that? There's a way you could fix that. Is activated. Before I jump back to start, let's put sleep 2. That tells it to sleep for 2 ticks. Sleep 2. Now, if I export this, that should never happen again, because now I said, okay, after you change it, wait for 2 ticks. Maybe 2 ticks is too long. There, it is too long. Watch, if I click it real close, it's still sleeping. Yeah. Let's just sleep for 1. Sleep 1 tick. Sleep is just telling the computer, wait here for a couple of seconds. I use that quite a bit, and especially in things like when you're unloading devices, because okay, so now it's not doubling up. This is one of the reasons I don't like buttons. Switches are just one position or another position. Yeah, it's still doing it. So buttons, you're going to have to expect that issue. There's no way around it. Switches are either one condition or another, and it's an instantaneous thing. Buttons, see how it stays activated for a little while? If you mistime it, there it goes. If you mistime it, it's going to fault on you. But that's just a character, I guess, of a button. That's why you don't really want to use a button to turn things on and off like this, unless you want to do it and wait. If you do it slowly, it should work fine with that sleep in there. But there you go. That shows you a flaw in the button in my book. But okay, so there we go. If you have any questions, I'll scroll through this. Maybe you can use your phone and take pictures if you have any questions about how I did this. I'll scroll slow, scroll slow. So that's kind of a complicated way of doing this. Maybe in the next video I'll get into the same program and I'll show you how to define LEDs. Now when you define them, you can't use them individually like this, so I won't be able to turn them on and off with a switch. Maybe I can. I'll have to think about that. I can turn them all off or all on, because when you define it, then you're defining all LEDs. So I don't think I'll be able to individually control the 2 switches. But at least it'll show you what a define does. But there you go. I hope this was helpful. If you find this helpful, beginning programming using buttons, switches, and levers, please subscribe and like. I'm going to do a series on these. If you want to know a specific device and how to control it, let me know in the comments, and I will put that in here. Maybe I'll show how to read things, how to send, I showed you how to control the colors up here. It's all a matter of IC programming. Very simple once you get to learn it. Well, not very simple. Easy and fun. Let's put it that way. There should be a space there. But there you go. If you want to see anything specific, let me know. I think that worked pretty well. Had a couple of things to debug. Showed you how to debug. That worked out pretty well, actually. Like I said, it's always hard to program in a video because you never know what you're going to fat finger, what you're going to do wrong. So, there you go. Navy Old Salt Gamer, please subscribe and like, and I'll be doing some more of these. Thanks.